Have you ever stopped to think that everything we call life unfolds under the invisible shadow of time? But what if I told you that time, the very thing that dictates our days and limits our dreams, might not even exist? Sounds crazy, right? Yet, philosophers and scientists have been wrestling with this question for centuries, and the answers might completely change how you see reality. After all, is time a universal truth, or just a construct of our minds to bring order to chaos? Imagine this. While you're racing against the clock to meet deadlines or anxiously awaiting the future, great thinkers like Einstein, Kant, and St. Augustine were questioning whether this invisible tyrant is as absolute as it seems. Are we prisoners of an illusion created by our own minds? And what would happen if we discovered that time, as we understand it, is just a trick? If that doesn't spark your curiosity, perhaps the idea that your perception of past, present, and future is completely malleable will. Aristotle viewed time as intrinsically tied to movement, something that exists only because change occurs. Imagine the sunrise. Time seems to flow as darkness transitions to light. For him, without the motion of things, time would be like a straight line without points, empty and non-existent. This perspective still resonates today when we measure time through movement, like the ticking of a clock or the changing of seasons. Aristotle reminds us that perhaps time, as we understand it, depends on something tangible, the constant transformations around us. St. Augustine, on the other hand, brought time into the mind. He believed the past lives in memory, the future in expectation, and the present is an ephemeral moment that slips away as we try to grasp it. Think about the last time you eagerly anticipated something. Your mind already experienced the future as if it were real. For Augustine, this is the magic of human thought, our ability to live outside the now. This concept applies to our daily lives. Planning, dreaming, and learning from the past are ways we manipulate psychological time. Kant dismantled the notion that time exists independently. For him, time is a filter the human mind uses to process experiences. Without it, nothing would make sense, like watching a movie where all the scenes are projected at once. Can you imagine a world without this structure? Perhaps that's what makes the mind so fascinating. It creates order from chaos. But is the mind the only one responsible for this? Let's find out as we bring science into the conversation. The central question is this: does time exist independently of us? Or is it merely a creation of our minds? For some philosophers and scientists, like Newton, time is absolute, a universal backdrop where events unfold. Imagine a constant metronome marking each moment with precision, whether on Earth or in the farthest corners of the cosmos. This perspective is comforting because it suggests time is reliable and unchanging. But is that enough to explain the complexity of our experience with it? On the other hand, many argue that time is nothing more than a mental construct. St. Augustine and Kant, as we've mentioned, align with this view. For them, time exists only because we perceive it. Think about a dream. Have you ever noticed how it seems to pass in the blink of an eye, even though it's full of events? If time were objective, it wouldn't distort like this. This view has practical implications. Perhaps we can reshape our relationship with time. Who hasn't wished to make time last? Techniques like mindfulness, for instance, help slow our perception of time, bringing us more fully into the present moment. There's also an intriguing middle ground. Time might be both, something that exists out there, but only accessible through the lens of our minds, like a song that we can hear only when tuned to the right station. This duality sparks fascinating debates that cross the boundaries of philosophy, physics, and psychology. But what does science have to say about this? Let's dive into that perspective next. In classical physics, Newton gave time an almost divine status: absolute, universal, and linear. It's as if the universe has an invisible clock marking the passage of seconds equally for all places and moments. For Newton, time didn't depend on the observer. It was a constant, an unbreakable straight line. This is useful for our everyday lives. Train schedules, production cycles, and even the countdown to New Year's rely on this orderly view. But is time really that simple? Then came Einstein, who disrupted everything, in the best way possible. With his theory of relativity, he showed that time is not absolute but relative. It depends on where you are and how fast you're moving. For example, imagine an astronaut traveling at high speed through space. For them, time passes more slowly than for someone on Earth. This concept, called time dilation, forces us to rethink the idea of a universal clock. In practical terms, it's essential for technologies like GPS, which adjust satellite clocks to account for these differences. But relativity didn't stop there. Einstein combined time and space into a single entity, space-time. He demonstrated that events don't just happen in time, but in space-time, a flexible fabric that can be bent, stretched, and even torn. This perspective makes us question, if time can be altered, how does that affect the idea of a fixed future or choices that shape our lives? This brings us closer to an even more intriguing question. Why does time seem to flow in one direction? The concept of the arrow of time is almost poetic, a unique direction, always pointing from the past to the future. But why does time follow this path, and not the reverse? The answer may lie in the second law of thermodynamics, which teaches us that entropy, or disorder, always tends to increase in closed systems. It's like breaking a glass. It shatters easily, but putting the shards back together is another story. This irreversibility is what gives time its arrow, pushing it ever forward. Think of the universe as a cup of coffee that cools slowly. Over time, energy disperses and chaos increases. This principle not only explains why time seems to flow, but also why we feel it's finite, a sort of cosmic clock, ticking forward as the universe marches toward greater disorder. Even in our daily lives, this makes sense, from fallen leaves scattered in the yard to gray hairs appearing with age. Everything seems to obey this logic of temporal progression. But what if we could manipulate this arrow? Some scientists speculate about the possibility of reversing entropy in small systems. Imagine a freezer that could turn back time to refreeze your drink, even after it's melted. Fascinating, right? However, on a larger scale, this reversal seems unlikely, at least in the universe as we know it. This idea leads us to even more mysterious territory, the domain of time in quantum physics, where the rules seem to bend. In the quantum world, time becomes an even greater enigma. While classical and relativistic physics suggest a defined rhythm, quantum particles show us that reality is far stranger. For instance, try pinpointing where a particle is and the exact moment it's there. It's impossible. This uncertainty, known as the Heisenberg uncertainty principle, places time in a fluid, undefined state. It seems that, at microscopic scales, time loses its linearity and can even intertwine in ways that defy logic. There are theories suggesting that time, on a quantum level, might be more like a network than a straight line. Have you heard of quantum entanglement? Two particles separated by millions of kilometers can instantly influence each other, defying the idea that time and space impose limits. This raises profound questions. Could time, as we know it, be just an emergent illusion of something far more fundamental? To illustrate, think of a hologram. It appears three-dimensional but is actually two-dimensional. Perhaps time is a hologram of our perception. And what about ideas that completely break with our intuition? Some quantum theories propose that events might not have a fixed order, as if effects could precede causes. Imagine watching a movie where the ending happens before the beginning. While this seems absurd, nothing in quantum physics is simple. These ideas lead us to explore how time connects with something essentially human, our consciousness. How do we perceive this complexity in our everyday lives? Time, for us, isn't just an external measurement but a deeply internal experience. Our minds turn the past into memories, the present into perceptions, and the future into expectations. Have you noticed how a day can feel endless when you're bored, but a joyful moment flies by in the blink of an eye? This phenomenon isn't in the clocks, it's in our consciousness. Psychologists point out that how we process time depends on our attention and emotions. Try this. The next time you're feeling anxious, take a deep breath and focus on the now. You'll notice how your perception of time can change. Memory plays a crucial role in how we perceive time. Imagine a book with blank pages. Without memories, the past becomes a void, and our connection to time dissolves. Similarly, our ability to anticipate the future allows us to plan, dream, and create. This is why practices like meditation or journaling are so valuable. They train the mind to navigate internal time with greater clarity. Try setting aside 10 minutes a day to write about a future goal. You might find it brings the future closer to the present. However, our relationship with time isn't without dilemmas. Often, we're stuck in the past or worried about the future, forgetting the present. Human consciousness lives this paradox of mentally traveling through time while being confined to the now. This makes us wonder, can we truly transcend this limitation? And what happens when we imagine not just living in time but manipulating it? Temporal paradoxes and the idea of time travel bring even more thought-provoking debates to the surface. What if time didn't exist at all? This idea, though it may seem absurd at first glance, is gaining traction in both contemporary physics and philosophy. Some scientists and thinkers suggest that time might be nothing more than a construct of our minds, a device created to make sense of the universe's chaos. It's like looking at a map. It's useful for navigation but isn't the actual territory. Similarly, time might just be a mental map we've created to organize events and experiences. But if time isn't real, how do we explain our everyday experience of it? Physicists like Julian Barber propose that the universe consists of now moments, timeless snapshots that exist independently. For Barber, the sensation of time flowing is an illusion created by our consciousness, which links these moments linearly. Think of a photo album. Each picture is static, but flipping through it quickly gives the impression of motion. Could life work the same way? This perspective challenges everything we assume about time and even causality. What comes before and what comes after? Others suggest that time is an emergent property, something that arises from more fundamental interactions in the universe, like quantum gravity. In this case, it would be more like a reflection, a shadow of something deeper. Imagine looking at a lake and seeing the reflection of trees. The reflection is there, but it isn't real in itself. These ideas force us to rethink the very nature of reality. What if time is just a temporary tool for our understanding? But before we dismiss its existence, let's consider how it came to be and how the expansion of the universe shapes it. In cosmology, time takes on an even more impressive dimension. It is thought to have begun with the Big Bang, approximately 13.8 billion years ago. Before that, there was no space, no matter, and, according to the most accepted theories, not even time. Imagine trying to measure seconds in a place where not even the hands of a clock can exist. From the Big Bang onward, time began to flow, marking the expansion of the universe and the formation of everything we know, from galaxies to subatomic particles. As the universe expands, it also influences our perception of time. A practical example: the light from distant stars we observe today might have left millions or even billions of years ago. What we see in the night sky is essentially a window into the past. Moreover, the acceleration of the universe's expansion, driven by dark energy, raises intriguing questions. What does the future of time look like? Will it continue indefinitely, or will it eventually dissolve along with the universe? Speaking of the future, there are theories suggesting that accelerated expansion could lead to a big freeze, a state where the universe becomes so cold and dispersed that the concept of time loses all meaning. It's both frightening and fascinating. After all, if time can end, what does that mean for our existence? These questions leave us in a place of mystery and remind us how time is a theme that unites philosophy, science, and humanity. So, after exploring so many mysteries about time, the question remains: how are you using yours? Are you living stuck in the past, anxious about the future, or truly enjoying the present? Remember, the way we perceive time is directly linked to our choices. Are you letting the tick-tock of the clock dictate your life, or are you willing to question it all and create a new relationship with time? Now is the time to act. How about trying techniques like mindfulness to anchor yourself in the present, or even studying more about these fascinating theories? Ask yourself, what would you do differently if you knew time was just an illusion? And more importantly, how can you turn this discovery into practical change in your life? If this journey has sparked your curiosity and you want to keep learning about such profound and transformative topics, subscribe to the channel and turn on notifications. That way, you won't miss any new videos and can keep expanding your mind. Let's challenge what we think we know and dive even deeper into the questions that truly matter. See you in the next video.